I'm Anil Kumar sharing with you an excellent question from my subscriber. This is probably the best question I have received this month. And you may see such questions in IIT JEE test papers. The question here is, describe characteristics of f of x equals to 1 divided by 2 minus 1 over 2 minus 1 over 2 minus x, where x is not equal to 2. Now we'll talk at length about this question. Many objective type questions can be created from here, right? So let's kind of understand the function as such. So what we are given here is a function f of x, which could be written as, so let me rewrite this. So we'll start from the bottom part to simplify it. So we have 1 over 2 minus 1 over, so we're writing 1 over, so I've copied that much. Now here in this part, we can take a common denominator of 2 minus x, right? So let's take this denominator common, 2 minus x. Then this 2 gets multiplied by 2 minus x. So I'm writing here as 2 times 2 minus x minus 1 over 2 minus x. Is that clear to you? So I've taken this common denominator here. So in step 1, I'm simplifying this portion. Is that clear? Now, as soon as we do this step, make a note of what x value cannot be equal to from the denominator. So we check from here that as given, x is not equal to 2. Okay? Let's simplify this expression a bit. So we'll rewrite again this expression as 2 minus 1 over, let's open this bracket, 4 minus 2x minus 1 over 2 minus x. Now this could be written as 1 over 2 minus, so now 2 minus x can be taken in the numerator, so we get 2 minus x here, and that simplifies to 3 minus 2x. 3 minus 2x. Is it clear? So as soon as we get 3 minus 2x, we note that x cannot be 3 over 2. So let's add one more expression here for restrictions. X is not equal to 3 over 2. Correct? So this we have got from here. Because x equals to 3 over 2 will make this something over 0, which is not defined. Is that clear? So see how restrictions are being added as we simplify this particular rational function. So let's move forward. What we can now do is we can write this as taking 3 minus 2x as common denominator, we get 2 times 3 minus 2x, and here we have minus, let me put this in brackets, 2 minus x over 3 minus 2x. So clearly I can take it in the numerator, write this as 3 minus 2x over, let's simplify this portion, 3 times 2 is 6 minus 4x minus 2 plus x, or 3 minus 2x divided by 6 minus 2 is 4, and minus 4x plus x is minus 3x. So now we get a rational function which is very familiar to you, right? 3 minus 2x divided by 4 minus 3x. However, here we have introduced one more restriction. Perfect. Now this restriction is that x is not equal to 4 over 3. Do you see that? So what we can say from here that the given function is equal to 3 minus 2x divided by 4 minus 3x, where x has some restrictions. X cannot be equal to 2. It cannot be equal to 3 over 2, 1.5 that is, and 4 over 3. Right? So let me rewrite here that f of x is equal to 3 minus 2x over 4 minus 3x, where x is not equal to 2 or 3 by 2 or 4 by 3. Is that okay? So these are the three restrictions on the given function. Perfect. Now we can actually discuss the characteristics once we simplify it. But I hope these steps are absolutely clear. Right. So let me rewrite this function here, and then we'll continue describing the characteristics. So we just found that f of x could be written as 3 minus 2x divided by 4 minus 3x, where x is not equal to 2, x is not equal to 3 over 2, and is not equal to 4 over 3. Perfect. So these are all the restrictions. Now at the end, we get this particular expression. Let's try to write down the characteristics of this function. Now that should not be difficult for you. You can always pause the video, answer this particular question, and then check with my solution, right? So one part is very clear. We got domain where x is all real numbers except these three. Now let's try to sketch this function here. Okay, so we have a vertical asymptote which makes this 0 because of this point x equals to 4 over 3, which is slightly more than 1. So let me just roughly draw a line here indicating this is x equals to 4 over 3. Is it okay? So more than 1, less than 2. Okay, so let's say this is 1, this is 2. Okay. Now, so that becomes minus 1, and this is minus 2. Fine. Now, what is the horizontal asymptote? Let's write down. So vertical asymptote is at x equals to 4 over 3, and horizontal asymptote will be when x is very large, these two values are going to be very small, and therefore the function is going to approach 2 over 3, right? So horizontal asymptote is y equals to 2 over 3, which is slightly less than 1, correct? So let me draw horizontal asymptote as kind of like this. Okay. Now from here, if I substitute x equals to 0, so what is f of 0 equals to? F of 0 is 3 over 4. So we know this is 2 over 3, right? So, 2 over 3 and 3 over 4. So what we get here is, now 3 over 4 is slightly less than 1, however, it is more than 2 over 3, right? If I multiply this by 3, I get 9, and this by 4, I get 8, so that makes a difference, or convert to decimals, right? So that becomes the y-intercept. So y-intercept for us is going to be slightly less than 1. So let me sketch a rough graph here. It is going to approach here from positive side, and it's going to be kind of like this. Is it okay? Where this point here, the y-intercept is 3 over 4. Okay, now let's find the x-intercept. So for x-intercept, f of x should be 0, right? So f of x equals to 0, or that implies 3 minus 2x is 0, or x is equal to 3 over 2. Now, so that means x equals to 3 over 2, but 3 over 2 is a restriction also, right? So since 3 over 2 is a restriction also, what we can say here is that we will have a hole at 3 over 2, right? So we have a hole at x equals to 3 over 2, right? Since while we were simplifying the expression, we did see that at one point denominator was 0. Perfect. So let me show you back the result. So at this stage, that becomes 0. So definitely we cannot have x equals to 3 over 2. But it gives you an idea that at 1.5, the value will be kind of, we'll have a hole here. So basically, I can actually sketch the graph now with this value. That is to say, it is going to approach the horizontal asymptote, but a hole at this point. Do you see that critical part here? You could make a mistake here. So that is kind of very critical to understand. So I hope with this, you can clearly see how the function is going to look like. Now this point here is 3 over 2. We have a hole at 3 over 2. Does make sense, correct? Now from here, you can actually write all the characteristics of the rational function. So the important point which you note is that we do have a hole at 2 also. So let me substitute 2 and find the value of f of 2. So at f of 2, I have to make a hole, but let me just substitute and get a value here. So if I write 2 here, I get 3 minus 4. I get 3 minus 4 over 4 minus 6. 3 times 2 is 6, right? 4 minus 6. That gives me minus 1 over minus 2, or it is half. So at 2, we have another hole. Perfect. So we have 2 holes here. At 2, that is the value, half, right? So I hope you understand that we have hole at we could write this as a coordinate point, 3 over 2, 0, and at 2, half. Perfect. So we have 2 holes. We do have a vertical asymptote and a horizontal asymptote. So that gives us all the 3 restrictions which we had pointed out. So basically, we have a domain of x belongs to real numbers where x is not equal to 2. It is not equal to 3 over 2 and 4 over 3. Correct? And we have a range where y belongs to real numbers, but y is not equal to the horizontal asymptote, which is 2 over 3, and y is not equal to 0, and y is not equal to half. So that becomes the range of the particular function. Is that very clear, right? So I hope you get most of the concept from this particular simplified version of the rational function. This is itself a very, very unique example where you have multiple holes which you could only appreciate after simplifying the expression, correct? So let's summarize the characteristics with, let's repeat the diagram again and summarize all the characteristics for this particular graph. So let's say this is the horizontal asymptote, that's the vertical asymptote. And what we really found was that it has 2 holes. One is at on the x-axis itself, the other one is at x equals to 2, right? So that was one hole, and then these 2 holes, and then we did find that it approaches from the top on the left side. So that's the graph of the function. So we could now write other characteristics as the function is increasing. We should write function f of x, right, is increasing in its domain, right? So we know what domain is, and it's increasing in its domain. So that means the rate of change of function is positive. Always positive. So when we say always positive, we mean domain, right? So So what is the domain? The domain of the function is that x belongs to real numbers where x is not equal to 2 and x is not equal to 3 over 2 as well as 4 over 3. The range of the function is y belongs to real number where y is not equal to 0, that is one whole, and the horizontal asymptote and the value half, right? So half and the horizontal asymptote, which is y equals to, we found that this could be written as 3 minus 2x over 4 minus 3x. So 2 over 3. Perfect? Right. So that is how actually you could describe, and some of you, if you've learned the end behavior, you could say when x approaches negative infinity, y approaches 2 over 3 from positive side, and when x approaches positive infinity, y approaches 2 over 3 from negative side, correct? So these are some other characteristics which you could define for the given rational function. Now I could always have multiple choice questions based on domain and range for this particular function, which is very critical. So I'd like you to go through this video once again, try to see it from different angles, also learn how we simplified and I found restrictions in the domain of the function. Thanks a lot for posting such brilliant questions. I really appreciate it. Feel free to write your comments, share my videos, and if you subscribe, that'll be great. Thanks a lot.